Good morning, guys. How are we doing, guys? Admit all. Okay, we got chat. Good morning. Excellent. Just letting everybody else get in here for a minute. All right. All right. Okay. Okay, fifth hour. I have January 5. Then we. And then we have Jan 6. Okay. For fifth hour, I see one Jones, one Graven, Maddie Davis, I'm assuming, and one Isabel. No Emma today. Okay. All right. I think we have a full roster then at this point. Everybody go ahead and pull up your slideshow because that's where we're going to start here today. So go ahead, make sure you have the slideshow pulled up. Okay, invite link, apply, Control V. I apologize for the delay here, folks. I have a new student trying to get in with us here. Okay. All right, here we go. Share screen, share screen, share screen. Can everybody see the slide deck? Can everybody see the slide deck on your screen? Yes, excellent. So if you weren't here yesterday, you owe me a mandatory Zoom right there. It is also an whoa, hey now. It is also an ed puzzle, so make sure you answer all those questions and make sure they're done because I'm going to be putting grades in Friday or Monday. That will cover slide 2, 3, 4, and 5. 2, 3, 4, and 5. So that will get you taken care of for those. That was yesterday's meeting. Now, what we're going to do today is we're going to work on polynomial addition and subtraction. So here we go. In this case, can everybody see my pen? Can everybody see my pen? Put it in the chat. Yes, excellent. Okay. So as long as you can see my pen, we can get started. Now, if we have polynomials like y1 equals 3x squared plus 2x plus 7, and we have y2 equals 4x squared minus 3x plus 2. We have something like this. And if I want to add them, how would I add this polynomial to that polynomial? Any suggestions? Put it in the chat. What would I do to try to put this together with this? Combine like terms, I agree with you 100%. Very good. So in this case, I have it in parentheses because this is a polynomial and that's a polynomial, but I don't know that I really care because all I'm going to do is add like terms. So 7x squared minus 1x and 7 and 2 is 9. The only thing kids mess up on this is when they put 3x squared and 4x squared together, they go, ooh, 7x to the 4th. But remember, you're just adding. So if I have 3 of them over here and I have 4 over here and I put them together, I just have 7. 7 what's? 7x squared. They don't change. So all we did was combine like terms. Now let's do the subtraction. So I got 3x squared plus 2x plus 7 in parentheses minus 4x squared minus 3x plus 2. Now, why is it actually very important that I have parentheses in the subtraction when it was not important that I had them in the addition? Why is it important to have them in the subtraction when it wasn't important to have them in the addition? Put it in the chat. This is not a spectator sport. Folks, what do I need to do to this negative if it's outside parentheses? One word would suffice. What would I do if I had this? What would I need to do up here with this 3? Thank you. Distribute. In this case, I'd give the 3 away. Here, I'm not going to just subtract the 4x squared. I'm going to subtract a negative 3x. So what I'm going to do is I'm actually going to make that a positive and switch all the signs here. So that when I switch all the signs, now I have 3x squared minus 4x squared is negative 1x squared. 2x plus 3x is 5x. And 7 minus 2 is plus 5. So there's my answer there because I had to give away that negative. The same thing happens with a monomial multiplication. Now, mono, what does the word mono mean? M-O-N-O. Mono. Mono means what? 1. Very good. So if I have something like 3 times x plus 2, give it away, 3x plus 6. That's a monomial multiplication. That's a distribution. But I could also do it like this, 2x times 3x minus 7. And so we have this, 2x times 3x. Now, earlier I said when you're adding that the exponents don't change. Be very careful. 3x squared plus 4x squared is 7x squared. But here, when I multiply, 2 times 3 is 6, but I'm multiplying now, not adding. So x times x, well, x times x is x squared. So 6x squared. Now 2x times negative 7, I get, whoa, not 16. I'm very special there. Negative 14x right there, just like that. So I'm giving it away. Now, ladies and gentlemen, actually just in this case, just ladies. All right, so here's what I need from you. What I need from you is I need you without a calculator to do the following multiplication. $6,324 times 24. Do it on your scrap piece of paper. Go, and I'm going to ask you the answer here very quickly. Now, to do this multiplication, what's the very first thing I do, guys? What's the very first thing I do to multiply this without a calculator? Thank you. 4 times 4. 4 times 4 is 16. Now, but I don't put the whole 16 down here. I leave the 6 and I put a 1 up here. Then I do 2 times 4. That's 8 plus another one is 9. Then 3 times 4 is 12. And I put a 1 up here and that's 25. What do I do before I can start dealing with the 2? What do I need to do before I can start dealing with the 2? Add a 0, that's right. Because this was the ones place, now it's the tens place. So I get 8, 4, 6, and 12. How do I finish this problem up? Add them up. All right, 6, 7, put a 1 up there. 7, 11, put a 1 up there. 5, 1, there you go. And there's my answer, just like that. Why did we do long multiplication in a class where we're supposed to be doing geometry? Well, because we got some algebra that we got to talk about. Because as we talked about yesterday, the algebra ties to the geometry. But in specific, how do I multiply 3x squared plus 2x plus 7 times 3x plus 5? How do I multiply those together? If it helps, this is a horizontal method, means it's laid out sideways. If it helps, I could do it this way. And this method is called the vertical method. Which one do you want to do? Do you want to multiply horizontally or vertically? Vertically. Here we go. Well, gee, this is why we did that a second ago, because it's exactly the same thing. 7 times 5 is 35. The only difference is we don't need to carry. 2x times 5, 10x. 3x squared times 5 is 15x squared. Now, when I go to do the next piece, I got 3x times 7, that's 21x. Where does 21x go? Does it go under the 35, the 10x, or the 15x squared? Where does 21x go? Below the 35, the 10x, or the 15x squared? below the 10x. Very good. Now, what sign do you use? Well, that's positive, that's positive. The whole thing is positive. That's fine. 3x times 2x, 6x squared. 3x times 3x squared, 9x to the third. Just like last time, how do we finish our problem? Add. Thank you. 35, 31x, 21x squared, and 9x cubed. Very good. And the signs that go between them, if they're positive, they're pluses. If they're negative, they're minuses. Pretty easy peasy lemon squeezy. Okay, so that is adding, subtracting, and multiplying polynomials. Now, that shouldn't be a huge challenge for you. It does follow the same rules as elementary school. But you guys have more than enough to accomplish. This was assigned yesterday. And today I'm assigning slide 6 and slide 7. They're due Monday. Ladies and gentlemen, get your stuff done. Make sure you're doing your work daily, because if you fall behind, it's a problem. Get off to a good start, guys. Get off to a good start. All right, that's what you have to work with. See you later.